Dumelang Abshina Sanbonani Molweni 200. Hello. Welcome to Sankofa Tutorials. Please hit the like button, the subscribe button, the notification bell, and share the information. It will be great if it helps you to mellow more, right? Okay, today we'll be doing grade 11 content. I'll be doing 2 questions, question 2 and question 3. I'll be simplifying, and also I'll be delving into patterns, number patterns. Now, let's begin without wasting any time. Okay, we have our first question: simplify without the use of a calculator. When they say without the use of a calculator, only as a calculator, guys. But I like this question. Even if we're full of a calculator, you can, right? So let's dive into the first question. The first question says, 2.1.1, you have exponents. So most of them exponents, you must know exponential laws. Guys, go back to whatever grade. I think exponential laws in Natala grade 8. So you've been doing exponential laws for 4 years, much. At this point, you must understand them. And remember, Sankofa, we read the instructions, and number 2, we number correctly, right? So our first question goes, open big bracket, 512. X to the exponent of 3, x to the power of 3 are equal. So x to the exponent of 3, that's 64. X to the exponent of negative 3, this is a value to the exponent of negative 1 over 3. So for 3 marks, must be solving. This will equals to, well, the first thing that I would do is use the law whereby further law square root. So a number must have the exponent must multiply the exponential, which is any number that doesn't have an exponent. We know it has an invisible one. So page 12 there's an invisible one. We know one was number. Now 64 we know one. That's the exponent. So in number in exponent a variable in the exponent there. Variable is your x. So uzoti 512 basically negative 1 over 3 times 1, which will be negative 1 over 3, and then uti x to the exponent of 3 nayo times more multiplied by negative 1 over 3. Remember, 3 is the same as 3 over 1. All over 64, now in the exponent of 1, so uzoleta the exponent lana, it's negative 1 over 3, and then it's x to the exponent of negative 3 multiplied by negative 1 over 3. So the negative 1 over 3 ongaphandle uzongena everywhere, uzongena ku-number, ku-variable, ku-number, na ku-variable. Manje sola, right? Now, to make things easier, since they said without the use of a calculator, you'll find prime numbers, waga 512 no 64. So a prime number 512 will be 2 to the exponent of 9, right? Multiplied by the exponent negative 1 over 3, right? Which will also be x, lena lezi cancelana, and then our final answer is negative 1. And then city all over 64 now gives us 2 to the exponent of 6 times our exponent negative 1 over 3, and then lazy nazo cancelana, and then you just have x to the exponent of 1 or x and then mawubuza ukuthi ngifike kanjani la, then kumele ngibuze ukuthi ayikhumbuli le method yase grade 9. That's how I got these answers. If you remember it very well, then usho ukuthi you are a true mathematician. U3 ungena kayi 3 lana, right? And then u3 ungena kayi 2 lana. So we have 2 to the exponent of 3, x to the exponent of -1. So that's our first one. In order for us to get here, we had to determine the product lana and the product lana, which gave us negative, and then lana it gave us negative na corner, and then it led here, right? And then since I'm a base afana, we take the big one here pansi. So we have x to the exponent of -1 over 2 minus 2 plus 3. Let's say na right? And then we have x to the exponent of 1. So here, when we take this one as a letter parts, because la x by a fan, then phezulu hayi ukuthi akusali next, kusala 1. So we have 1 over 2, bese uthi -3 plus its exponent of 1, which means it's 2. Then uthi x, low 1 low, plus low 1 low makayehla. And our final answer is 1 over 2x squared. This is our final answer for the first one. Okay, then we move to 2.1.2. Yo, I would say my number better. 2.1.2. So now we rewrite it pansi, then we simplify. Remember, simplify is not solve for n. Simplify means simplify, meaning your final answer must just be simple. We are not solving for anything. So we have 2.1.2, and then our expression is x to the exponent of n plus 2 plus x to the exponent of n plus 1 minus x to the exponent of n minus x to the exponent of n minus 1 all over x squared minus 1 equals to, we group them, then we take out the common factor, which is x to the exponent of n, basic sala x squared minus 1 plus x to the exponent of n, basic sala x minus x to the exponent of minus 1 all over x squared minus 1, which then equals to x to the exponent of n, x squared minus 1, close bracket, plus x to the exponent of n, x squared minus 1, all over x, manipulate my exponents are n, all over x squared minus 1. And then from lana, we do more manipulation lana, because they are one as number x squared minus 1, x squared minus 1, x squared minus 1. And then it can spell x to the exponent of n plus x to the exponent of n 1 over x. Keep x squared minus 1 as a common factor, and then they cancelled out. And then from lana, we solve this bracket, and then spell x to the exponent of n plus x to the exponent of n minus 1. Okay, any other method would work. Lana says, because of your screen, I couldn't show all calculations. Now then, after we manipulated this, we will be s squared minus 1, then we had the common factor. right? We take out the common factor, must keep the common factor as x squared minus 1. The x squared minus 1 cancel and x squared minus 1 lazy, right? Marisa common factor, not the way it's cancelling much. And then from lapho salanga logo. And then from us to get from here to here, you say x to the exponent of -1, which means we reverse a definition of x. And then when you say x to the exponent of -1, you have a base afanayo, and then they give you x to the exponent of n minus 1. Right. Someone else can take out x to the exponent of n, then the final answer is x to the exponent of n 1 plus. Now when you simplify, it's better to leave equals alcohol without a bracket. So that's the most cleanest way to leave your expression. Okay, again, since you go 2.1.3, then let's go 2.1.3 on a square root, say square root, do square root, say square root. Might look difficult, but it's not actually, especially if you understand the surds, the product rule, the quotient rule, because I just see a product rule. So once you have the rule, better into setting. Okay, so it's 2.1.3, and then we have square root and a plus the square root of 2a minus 1 multiplied by square root a nayo, or then it's minus square root of 2a minus 1. Now according to the product rule, right, when you have square root of a multiplied by square root of a, these two can go under the same square root. So you can have square root of a squared, right? So now, since they said multiply, it means we are using the product rule. So they said square root of this and then square root of this, which we can put them under one big square root, right? So we can say, okay, according to the product rule, that means this is the same as when we multiply these two under a one big square root. So it will be a huge square root, whereby the a plus square root of 2a minus 1 pounds, then multiplied by a minus square root of 2a minus 1. Right? I'm a bracket, they stand for multiply, right? Mathematics. So from here, you notice what we have a plus something, a minus something, sort of like difference of two squares. So if you take it like a difference of two squares, it means then you can take the first terms whose multiply, whose square, you have a squared, and then you can take minus the last terms whose square also, which is 2a minus 1 all squared, right? Just using the principle of difference of two squares. Square root and a squared is a canceller. So what will you be remaining with? A squared minus 2a minus 1. Plus 1. No, minus 1. Right? In brackets. And then multiply, you take out the bracket, then you have a squared minus 2a plus 1. Distribute a negative inside of the bracket. And then this can be turned into two brackets. You can simplify it further. So you can have a bracket A2, and then number my AA number my multiply will put 1, my add you will put 2. So 1 and 1 minus n minus, and then this is a squared binomial my 1. So it's a minus 1 all squared. The squared and square root is cancel, and then our final answer is a minus 1. That's how you solve this one. It's long, right? Now that's why I put it by P4 marks, because by born with savings in a part. I hope you understand how we got it to the answer. And then it was too long. Okay, let's move to question 3. Minusing and Naguma number patterns, right? In case I post a video of it after Malang, we're having crazy internet problems lah. So they're still fixing them. In English, let me not even bore you with the details. Okay, so question 3 says, given the pattern tan x is to sine x is to sine x times cos x. And then that's where 3.1.1 explain how each term is found from the previous term. Now, if it was an arithmetic series, we'd have our plus and our minus, especially since we're dealing with trigonometric functions. But for a mere factor, which especially the third term is multiplied, sine x times cos x, then it shows which in order for them to get the next term, they are multiplying. So it means this is a geometric sequence. What are they multiplying with? Well, notice color tan x turns into sine x. Now, what can turn tan x into sine x? Tan x is sine x over cos x. So the only way to turn it into sine x is if you multiply with cos x. Because if you multiply with cos x, cos x by a cancel, and then you remain with sine x. So it means they are multiplying cos x to get the next term. So in order for us to answer the first question, we'll say that because they're trying to find out how are they getting amathemalandelayo. So we start by numbering. Remember some coefficients, numbering 3.1.1. So they multiply by cos x. They multiply or cos x to get the next term. And then we go to 3.1.2. And then 3.1.2, let's go to it, let's check it out. Write down the fourth term, T4 of the pattern. So we need term 1, term 2, and term 3. So since we said they multiply with cos x, which will multiply with cos x. So you'll have sine x times cos x times cos x, which will be cos squared x, because about cos x by 2, right? So it means our answer will be sine x multiplied by cos squared x. 1 mark. It's not difficult. Tricky. Mix trigonometry pattern, right? But beyond that, it's not that difficult, especially once you figure out it's a geometric pattern and it binds on it, then the rest becomes easy. Okay, now you are given a pattern. Now we are going to just straightforward patterns. But given the pattern -1, 2, 5, and 8, determine an expression for the nth term of this pattern. So the nth term is the general term, right? So they want you to find the general term of the pattern. Okay, must say by the parts so we can make sense of it. So it's 3.2.1. So they gave us -1, 2, 5, and 8. So first thing we need to find which is the geometric or arithmetic series. Always try the arithmetic first, if we are full as the geometry. So arithmetic says T2 minus T1 must be equals to T3 minus T2. So our T2 is 2 minus -1, because the first term is the negative, and then we also have a negative formula, which will be equals to 5 minus 2. So 2 minus -1 gives us 3, which is equals to 5 minus 2 gives us 3. The left-hand side is equals to the right-hand side, so it means it's an arithmetic series. Not only an arithmetic series, but a linear arithmetic series. So we have our constant difference, which is equals to 3. Now we are supposed to find the general term. General term Tn is equals to a plus open bracket n minus 1 close bracket d, and then we substitute to a way 2, which is -1 minus 1 plus our n asymptotic minus 1 no 3 we general term. Distribute u3, then you have Tn, which is equals to minus 1 plus 3n minus 3. Number like terms, minus 1 no minus 3. Now, minus 1 no minus 3. Our final answer becomes Tn is equals to 3n minus 4. Now this is our general term. Our general term kumele kube equation, right? It can't be just one answer. Kumele kube equation. So now that we found the general term, see question 3.2.2. So question 3.2.2, the one ekugcineni, it's which. Now kuma number pattern mawubona which target, right? You must know ukuthi uzo substitute Tn, right? Sifunana no n, right? So that which term of the pattern will be equals to 161. So they are trying to find out ukuthi n kuzoba yini if i-pattern yethu ifika lapho. Okay, we already have our general term. Siqala ngayo. Kumele siyibhale phansi. And then our general term is Tn is equals to 3n minus 4. So still on target, right? The question started with which, meaning which will be substituting here and we'll be looking for this, right? So 161 will be substituting with Tn, which equals to 3n minus 4. So solve for n major with transpose, which is 161 plus 4, which is equals to 3n. 161 plus 4 gives us 165, which is equals to 3n. We keep a lot 3 because n may be 1. We divide here by 3, divide here by 3, and then n will be equals to 55. So when you see the question number patterns, it's telling which term, which target, you must know which you are looking for n. Whatever number is if I would see n, and then you'll be looking for n, and then our n here is equals to 55. Okay, if this helped, if you are having some difficulty, please contact us Usanko for tutorialsa@gmail.com. And then remember, let me make this announcement again. If you want a private session, like now, uzobuza many specific questions that you have on specific question papers or specific topics, please contact us. We'll communicate with how can it be arranged. Everything is done virtually, so all you'll need is internet from your side, and then we can be able to tutor you online. Okay, thank you very much, guys. Sharp.